Remember, zero product property is going to apply when you have two factors that multiply to a result of zero. Right? They have to equal zero, not negative 24. They have to equal zero. Okay? So there's two ways that we can accomplish this. One way would be to add the 24 to both sides. I'll show you another way in a sec. All right. So if you do that, and you write it in descending order, because we don't have any like terms here, in descending order, we would have negative y squared plus 2y plus 24 is equal to 0. All right? So that's one way that you could accomplish getting the equation equal to 0. Another way, so let me duplicate real quick. Oops, I didn't use my lasso. The other way would be to move everything over to the right-hand side. All right, so instead of adding the 24 to both sides, I could subtract the 2y from both sides. I could add the y squared to both sides. And get 0 equals y squared minus 2y minus 24. All right, these two equations are equivalent to one another. All right, the equality concept, that's commutative. You could write it either way. So this is the same as y squared minus 2y minus 24 is equal to 0. All right, so you could go that route. Another way to handle it would be to do what we did in the first approach, but then we can multiply the entire equation by negative 1. All right? We could divide the entire equation by negative 1. All right? Because you can multiply or divide an equation by any non-zero numerical value. Now, I mean, if you want to multiply by a fraction, you could do that too. I don't know why you would want to, but I'm sure there would be a circumstance where you'd want to multiply an equation by a fraction, just not this one. So if you multiply this equation by a negative 1, you're multiplying all parts by negative 1, you would get y squared minus 2y minus 24 is equal to 0. All right, and you can see that those are equivalent equations. All that being said, you can still factor this just as it is using the trinomial techniques that we've gone over. All right, so we're up to 3 different ways to handle this, and none of them are wrong. All right, the only time with any of these problems where that you'd be looking at an incorrect approach would be if you left terms on both sides of the equation. You need to have 0 on one side of the equation, otherwise the zero product property would not work. All right, but once you get it into a form that's factorable, we go through the process of factoring. Y minus 6, y plus 4, set each factor equal to 0, and solve, and you get y equals 6 or y equals negative 4. All right. So not too bad once you get it into the appropriate form, but people tend to get thrown off by the negatives. All right, and like I said, I might as well just do one more. Let's do number 8. All right, that one's got terms on both sides also, but it's a little easier to kind of work out. So I would subtract the 10d from both sides. I'll do it in multiple steps here. 6d squared. We have like terms in this case, which is kind of nice. All right, so plus 11d equals 35. Subtract the 35 from both sides. 6d squared plus 11d minus 35 is equal to 0. Now it's in the appropriate form for factoring. just a question of what technique. Well, it's got 3 terms. There's no GCF. 11 is a prime number, right? And even if 11 was a 12, 35 is not divisible by the same numbers that 6 is divisible by. So you're not gonna be looking at a GCF situation here, right? So we're gonna be looking at factoring, but again, this is one of those cases where you're factoring with a leading coefficient that's not equal to 1. That's always a little bit trickier. So you could go the trial and error route, or you could go the graph and calculator route just to give yourself a clue as to what the factors might be. All right. So if you go that route, again, the left side of the equation goes in for y1 once it's in its appropriate form. And if you haven't at least practiced this or attempted this process once, give it a shot. Give it a try just to see, because maybe it's something that you find will be useful. I wouldn't want you to go into a test not having tried this approach at all. All right, so especially the Regents exam. All right, so I put my equation in, left side for y1, right side for y2. I do a zoom 6, standard zoom. I don't have clean intersections, but that's okay. Second trace 5. All right. Let's see. I'll go for the right one first. Oops, overshot the mark. Enter, enter, enter. 1.6 repeated. If I don't know what that decimal is in fraction form, then I go into my home screen, call up the x value, hit x. It'll bring up the decimal value, math, enter, enter. All right. So I know one of the roots is 5/3. The denominator corresponds with the coefficient of the factor. The numerator corresponds with the constant term of the factor. So this is going to have a 3x and a 5 in it. So now I could piece together, without having to do the second trace business, I could piece together the other factors. All right. The other one, oh, I shouldn't have wrote x. 3d. The other first term, so in the other binomial, the first term is going to be 2d, because that's how I'm going to get to a 6d squared. And to get from a 5 to a 35, it would have to be a 7. It's just a question of signage. All right. So your root is always going to have the opposite sign of your factor. So this root is positive, root or solution or x-intercept is positive, so my factor is going to be negative. If I'm going to get to a negative 35 through multiplication, then this one would have to be positive. And you could check it. Right? So we'd have 21, we'd have a negative 10, 21 minus 10 is 11, so that would check out. All right, so 3d minus 5 equals 0. You solve with all the hocus pocus, and you get d is equal to 5/3. Then 2d plus 7 is equal to 0. Do all your hocus pocus, but in this case you might want to show it. Especially if you have trouble figuring it out. So 2d is equal to negative 7, so d is equal to negative 7/2. All right. So this is going to come up on today's assignment because we're going to do some IXL work. What's going to end up happening is in the first assignment, you're going to be looking at just going from the factor form to the root form, and I keep going back and forth with those terms because you're going to need to know them all at some point. Roots, x-intercepts, solutions, they're all going to be synonymous. They're all going to mean the same thing. All right. So you're going to want to develop proficiency going from directly the factor form to the root form. All right. So if you take what we've learned about going from the root form to the factor form, it's pretty easy. Because again, the coefficient's the denominator, the constant term is the numerator, the signs are the opposite. Right? So you take those relationships and use that to develop some nice shortcuts. It'll help you complete the IXL quicker, obviously, but it'll also deepen your understanding of the content. Well, for any of them, we're applying the zero product property. So whenever we're dealing with that, we need to make sure that we have a zero product, as in two factors that multiply to give a result equal to zero, right? Meaning zero has to be alone on one side of the equation. So what I'm going to do here is I'm going to subtract the 32u and the 72 from both sides. All right, on the right-hand side, it's going to cancel out to 0. On the left-hand side, we don't have any like terms, and because of that, we can't actually combine them. So we can only write 2u squared minus 32u minus 72 equals 0. But at least it's in trinomial form. So when you're dealing with a trinomial, you got a couple of different possibilities to get started. One would be to just create the binomial framework, the two sets of parentheses. The other approach, well, it's really something you should always be doing, and that is look for a GCF. All right. So in this case, we have a GCF of 2, meaning we can divide each term by 2 and write it as a coefficient. And that's going to give us u squared minus 16u minus 36. All right. So now I have a trinomial, and I'm looking to determine the two values, because it's a trinomial with leading coefficient equal to 1. So two numbers that are going to multiply to negative 36 that are also going to add to negative 16. All right, it's when the leading coefficient is something other than 1. That's when you really got to get into the arc diagram and stuff like that. But this one isn't too bad, at least once you get to this step. So we know it's going to be u and u. And we want to be thinking about factors of negative 36. All right, so you might say 1 and 36. You know, one of them is negative. 2 and 18. All right, so if I try 2 and 18, I mean, you could do 9 and 4, you could do 12 and 3, but let's do 2 and 18. All right, my outer product would be 18u. My inner product would be 2u. That would work if the 18 is negative and the 2 is positive. All right, because negative 18 plus 2 would give you negative 16. So make the 2 positive, the 18 negative, and you have your factors. All right, so then it's just a matter of setting our factors equal to 0. Now we have 3 factors here, but one of them doesn't contribute to the product, in the sense that you could never get a 0 out of a 2. Like you can't just make a 2 into a 0. All right, so that's irrelevant. 2 can't be equal to 0, so disregard that one. U plus 2 could be equal to 0. U minus 18 could be equal to 0. All right, so we solve both of those for the variable, and we get u is equal to negative 2, or u is equal to 18. All right. And again, that 2 in the front doesn't factor into anything. All right, doesn't matter, or doesn't contribute to the solution. Just squaring up attendance here. I think I got it. Okay. So the next one would be number 14. All right, so number 14, same deal. Actually, a lot of them had this thing in common where one side of the equation needed to be equal to 0, but that wasn't the case, so we had to make an adjustment. All right. So here I'm going to subtract the 5x from both sides. You get x squared minus 5x minus 14 equals 0. Now it's in the appropriate trinomial form. So I'm looking for two numbers that are going to multiply to 14. So 7 and 2 seems like the most likely. And one of them needs to be negative. So negative 7, positive 2 outer product 2x, inner product negative 7x. That'll get you to a negative 5x. All right, so take each of your factors, set them equal to 0. And solve, and you get x equals 7 or x equals negative 2. All right, and that would be my solution. Folks, we got to wear the masks in here, please. Property tells you that you need to have two factors, or at least the way we use the zero product property, two factors that multiply to equal 0. Right? One key component of that is that it has to be equal to 0. Right? So whenever that's the case, you need to get 0 alone on one side of the equation. All right? So whenever you're applying the zero product property, you have to get 0 alone on one side of the equation. So the only way we could do that is by adding the 8x squared to both sides. All right? So that gives me 8x squared plus 2x minus 1 is equal to 0, because it cancels on the left, on the right, and it's now introduced on the left. But we have to have it in descending order. I saw a lot of people struggling with that. All right? So the highest power comes first, then the next highest power, then the power after that. All right? So then we recognize it as a trinomial. There's no common factor. So open two sets of parentheses. We look for two numbers that'll multiply to 8x squared. We look for two numbers that'll multiply to negative 1, but let's say you're struggling with that. Because a lot of folks struggle with the leading coefficient not being equal to 1. So you could go into your calculator, type in the left, once you get it in the appropriate form, type in the left-hand side of the equation. Put in 0 for y2 and do zoom trace. So zoom 6. If you have a hard time seeing the x-intercepts, remember x-intercepts, roots, solutions, they all mean the same thing, you can hit zoom, zoom in, and hit enter, and it'll give you a better look. Now, it's pretty clear that the roots are not that clear, right? Meaning they're fractional. I don't know what they are, but I can figure it out with the calculator by hitting second trace intersect, option 5. All I need to do is find one of them. Enter, enter, enter. It gives me 0.25. All right, that's nice and easy because I could recognize that as a fraction. X is equal to 1/4. All right, not always that easy. All right, so let's say you had a funkier decimal value. If you did, you'd go into your home screen, hit X, type that X key in, hit enter. It'll bring up that decimal, and then you math frac it. Bring it over to fraction form. So math, option 1, enter. And then it'll convert it for you. All right. The benefit of having the root is twofold. One, the denominator takes on the role of the coefficient in the factored form. So if you have the root, the denominator becomes the coefficient, the numerator becomes the constant, and the signs are opposite. So whatever the sign is of your root is going to be the opposite of the sign of your factor. So I'm looking at a 4x minus 1. All right, and you can verify it. You know, you take that 4x minus 1, pull it out, set it equal to 0, add the 1 to both sides, you know, that old thing, that old chestnut. 4x is equal to 1, divide both sides by 4, and you get your 1/4. All right, so I have one of the factors. So then it's like, how do I get the other factor? Well, how do I get from a 4x to an 8x squared? I need a 2x. 4x times 2x will give me 8x squared. How do I get from a -1 to a -1? I multiply by a +1. All right, so I would have 2x plus 1 is equal to 0, my or symbol. And then I would solve that, subtract 1. So 2x is equal to -1, divide by 2. And I would have x is equal to -1/2 as my other root. All right, and you'll notice here, the signs are the opposite. The sign of my root is the opposite of the sign of the factor. That's always the case. All right? The denominator of my root is the same as the coefficient in my factor. The numerator of my root is the same as the constant in my factor. All right? So it's a nice way to get from factor form to root form directly without having to do the algebra. It's a nice way to get from root form to factor form, same deal. If you have the calculator give you the roots, then you could always get the factors from that too. All right?